Well, welcome. I want to talk a little bit about number systems. I got a couple of videos here, maybe more, but at least two. In this video, I want to talk about number systems and introduce us to the binary number system. So first of all, binary stands for binary digit. In computer science, networking, all this good stuff, computers only understand one of two discrete states. We think of those as off and on. We represent them numerically using the binary number system, which we're going to talk about, as 0 and 1. But it's the only thing a computer understands. And I'm going to talk more about why that's the case in a moment. But we represent it as a lowercase b. And I mentioned we call it a bit. And it has one of two values. We typically think of those as off and on, 0 off, 1 on, or sometimes when we're dealing with digital logic, Boolean, 0 false, 1 true. But actually, inside the computer on the network, it can be anything. It can be levels of voltage. It can be different wavelengths of light or anything, just one of two discrete states. And what's interesting is sometimes an on-off button. You might not have noticed this, but the old days we had like something like this. It's really a 1 and a 0. And even newer devices now, you might see a little power button like this, and that's a 1 and that's a 0. Anyway, let's take a look here. So why do we use binary? Why is it one of two discrete states? So let's say we had more than one state. And I'm just going to use light, and if it was traveling over a distance. All right. So if we had 4 states, 0 off, and then 1 is a dim light, 2 is a kind of a normal light, and 3 is a bright light. Well, let's say we want to send somebody one of these 4, and we want to send them bright. So let's say it starts off bright, but as it travels, it attenuates. Laws of physics there. Okay, the signal weakens. So by the time it actually reaches the person, we meant it as this level, but what they're seeing, 3 bright, and they're seeing it as 2 normal. Or perhaps, we send it goes over even a longer distance. Maybe it started out as a 3 as a bright. By the time they got it, it's dim. So they're receiving a different value than what we're sending. Okay. Perhaps we're even sending it something like a normal light. And by the time it goes over such a long distance, that by the time they get it, they don't see anything. It's off. So this is why in computer technology, computer science, computer networking, we use one of two discrete states. So the state is either on or off. It's there or it isn't. It's present or it's absent. Sometimes call that panda. So, for example, if I'm sending this light, okay, and could be any brightness, okay, but it's just on. It's either on or it's off. That's it. So I send it over a long distance, as long as the signal has not attenuated to a state where they can't see it at all, they see it. It's either on or it's not on. Okay. Now, if that signal travels over a long enough distance where the signal attenuates to where the person can no longer see it, then that's, of course, a problem. This is why we have certain distance limitations in networking, in our length of our cables, how far a wireless signal can travel, things like that. But this is why it's one of two discrete states. Either it's there or it isn't. Very simple. All right. Oops, I didn't mean to do that. I mean to do that. There we go. All right. So let's talk a little bit about number systems. You know already about everything you need to know about number systems. Okay. First of all, our basic number system rules. I'm talking about integer-based number systems, not this stuff from other galaxies and things like that. I've talked to my brother, the physicist, about that kind of stuff. Anyway, basic number systems. So all digits start with 0. Okay. So a base, whatever number system, has that many digits. Okay, what do you mean by that, Rick? Well, decimal. Decimal is base 10, right? Has 10 digits. And we said here that every number system, the first digit starts with 0. So there we go, 0. And with 10 digits, well, 0 through 9. There's our 10 digits. Okay, all right. And if you understand this, you're going to understand any number system. Okay, so how about binary? Okay, binary is base 2. That means it only has 2 digits. Again, the first digit is going to be 0, but only 2 digits. So our second digit will just be a 1. Now, there's another number system we're going to talk about. Talk about that in the next video. Hexadecimal, base 16. Okay, base 16, same thing, 16 digits. We'll learn later what those digits, I'll show you right now what those digits are. Again, the first digit starts with 0. 16 digits. For our first 10 digits are 0 through 9. And our last 6 digits, we just use the alphabet. I'll talk more about that later. Okay, and I'll talk more later why we use hexadecimal. Okay, it's actually very useful. All right, so also, the other thing we have to remember is when we represent numbers, okay, the first column is always the column of ones. So, for example, in base 10, the rightmost column, okay, sometimes known as the least significant digit, is the column of ones. Now, base 10, okay, base 10 means each column after that is 10 times the previous column. So, for example, we start with a 1 here, right? This next column is 10 times the previous column, okay? Now, what about the next column? It's 10 times that column, okay? So each column is 10 times the previous column. Yep. All right, that makes sense, I hope. Now, same holds true for all the other number systems. For example, base 2. The first column is column of ones, okay? But the next column, I'm going to make that a little thinner here. The next column, first column is column of ones. The next column is 2 times the previous column. Why 2 times? Because we're talking base 2. Before we were talking base 10. Base 2 means each column, each successive column is 2 times the previous column. Okay. And the same holds true for any number system you want to think of. All right. Let's take a look at one more. We're not going to worry about too much right now, but we have first column, column of ones, base 16. Oh no. What's the next column? Well, it's base 16, 16 times the previous column. So we have a column of 1 there. My little zoom pen selection stuff gets in the way there for a second. But 16 times the previous column. And if I wanted to keep on going, and don't worry, we're not going to have to do a lot of multiplication in hex. Don't worry about that. But each column is 16 times the previous column. All right, let's get started a little bit here on binary. First of all, again, decimal. You already know everything you need to know about any number system. Okay, in decimal, okay, we have 10 digits we can start with, right? And we can put any of these digits in any of these columns. The first column is column of ones, column of tens, hundreds, thousands, etc. Showing the exponents above if you want to use that. Okay, so for example, I can put a 7 there. Now, if I have a 7 all by itself, we assume that it is in the least significant, the rightmost position. So that's just 7 ones. Now, if I wanted to mean, I meant 77 tens, I'd put a 7 followed by a 0. This 0 means that this position of the 0 is the number of ones, and this 7 here in the second position is the number of tens. Oh, okay. I know you're probably going, Rick, I remember this from second grade. Maybe they teach us sooner now. I don't know. What if I put leading zeros? Leading zeros mean nothing, okay? You can have as many as you want, okay? they don't change the value unless I put a number over here. But if I had all leading zeros, it's just whatever number's here. So, okay. Now, of course, zeros after a number does change the position of, in this case, the 7. Here we have the 7 and the 1s, 0, 0. It's just 7. Okay. 99. Okay. Well, in this case, I have 9 10s and 9 1s. Okay. Now, what if I added 1 to that value? What happens? Well, as you notice here, 9 is our last number, right? So if I added 1 to this number here, 99, I actually have to start over here. Let me go ahead and do that. I'll show you. Okay. What I do here is I start over, go from 9 to a 0, start over, and increase this next column by 1. Okay. Now remember, I'm adding 1 to 99. Okay, so I've increased this next column by 1. Well, that's doing the same thing. 9's the last number, put a 0 here. Okay. Then what do? Is I increase this next column by 1. Well, the next column is really 0. Okay, so it's going from 0 to 1. Now, if you understand that little rule, you've got it. You've got number systems down. Okay, let's do some examples of, if I start with a 0, I have nothing. I add 1 to it, I've got one more. I can go 2, 3, 4, 5, 6, 7, 8, 9. I get to 9. Okay, again, last digit. Okay, what do? I start over here and increase the next column by 1. And then I can go 10. I've kept on adding, go 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Again, last digit here. Okay, went from 1 0 to 1 1, 1 2, 1 3, all the way to 1 9. Now what do? Again, 0 here, increase the next column by 1. Now, why am I going over this? Because it works the same for binary and every other number system. Let's take a look. Okay, first of all, why are we learning binary? Well, if you're in one of my classes, I teach a lot of networking classes, and we use binary. For example, we're going to learn about IPv4 addresses. Everything is binary. Everything is bits, I should say, okay, in the world of computer science, computer networking. Okay, IPv4 addresses, don't worry about this right now, okay, but they're 32-bit addresses. And what we do is we don't want to say, hey, what's your IP address? Well, it's 1010110. No. What we do is we break it up into 4 8-bit bytes or octets. Okay. And we represent each of the 8 bits by a decimal number, and we put a period in between. We're actually converting this binary, and I'm going to show you how to do this in a moment, converting it from binary to decimal. Okay, I'm going to show you how to do that right now. All right, so binary, that's what we're working on. Binary is base 2. I should put that somewhere, okay? Binary is base 2. Okay, that's it. There we go. My writing here, base 2. Okay, what that means is there's 2 digits. First digit is a 0, always. We got one more digit to go. Okay, just a 1. There's our 2 digits. That's it. That's all we can use. Now, let's start there. Next, our first column is always the column of 1s. Now, what base are we in? We're in base 2. This means that the next column is 2 times that. Okay, I'll do it this way, times 2. Okay, 2 times, or 2, yeah, that doesn't really look good. 2 times 1 is 2. The next column is 2 times that. I should do it like this, makes it easy. 2 times 2, we have 4. Each column is 2 times the previous column, because we're in base 2. Right? Let's work with this a little, and it will make sense. All right. So how do we convert decimal, or I'm sorry, binary to decimal? Now, here's my columns: 1, 2, 4, 8, 16. I go all the way 128, keep on doubling all the way to infinity and beyond. The only value I can put, the only digit I can use in any of these columns is a 0 or 1. And that's telling me how much I have of this. Okay. So, for example, what if these were dollar bills? $1 bill, $2 bill, $4 bill, $8 bill, $16 bills. And I can give you 0 of it or 1 of it, and that's it. Well, if I gave you 0, you have $0. What if I gave you one $1 bill? Well, that's, you have $1, same equal in decimal. Okay, now remember, I can give you 0 or 1 of any of these dollar bills: $1 bill, $2 bill, $4 bill, $8 bill, etc. What if I gave you one $2 bill and 0 $1 bills? I give you one $2 bill, but 0 $1 bills. I've just given you $2. Now remember when we talked about incrementing numbers in decimal? When we got to this 1 here, there is no 2. We're at the end of our numbers. So what did we do? We had to start over with a 0. And we increased the next column. This is a 1 here. We increased it by 1, and that put the 1 here. Although you don't see this 0. That's same as the decimal, but we only have 2 digits to work with instead of 10 digits. All right, let's get back to this here. Okay, so as you can see, I gave you one $2 bill, 0 $1 bills, $2. Okay, let's increase this by 1 again. So I went from 0 to 1. Leave this alone, we're good still. I give you one $2 bill and one $1 bill. Now you have $3. 2 plus 1. Now, how do we increase this again? Well, how do I increment this by 1? Remember, I'm at the end here, right? So what do you think? This goes from 1 to what? 0. We got to start over. But we increased the next column by 1. Oh, well, we got to start over in this column again too, because we already have a 1 there. So let's increase that one by 1. Okay. So we got to start over 0 there. And although there's no 0 here, it's implicit. Okay, we're going to put a 0 here. We're going to increase that by 1. So what do you think we're going to have here? 1. Now look at this. Previously, I had one $2 bill, one $1 bill. 2 plus 1 is 3. Now look what we have. 0 $1 bills, 0 $2 bills, and one $4 bill. Okay, so yes, I'm going to show you that there. There we go. $4. So we have 4. So that's how we're incrementing. It works. Okay, just when we run out of digits, where we get to the 1, we increment, would make a 0, add 1 to the next column. Okay, here would be a 5. One $4 bill, 0 $2 bills, one $1 bill. And you might be seeing this. Wherever you have a 1, you just add that column. So here we have 2. Here we had a 1 here and a 1 here. So I added the 2 and a 1. Okay, here, this last one, I have a 1 here, so I'm going to add the 4. 0, not going to add that. There's a 0 here. I'm not giving you any $2 bills. And I'm going to give you a $1 bill. So I'm giving you a $4 bill and a $1 bill. I'm adding these two. 4 plus 1, 5. All right, let's do a couple of examples here. Okay, so here's our first one. Okay, this is our binary numbers. And I'm showing you the column headings. Okay, normally you don't see those, but I'm showing you the number 1s, 2s, 4s, 8, 16, 32, 64, 128. Okay, 2 times the previous column. And some of these just leading zeros, and that's fine. Okay. Now, we don't normally write out when we're writing numbers. We don't write like in decimal. I don't put ones, tens, hundreds, because we assume it's base 10. Okay. Now, there's ways that we designate a base, and we usually put that in a subscript. All right. Not always, though. All right. We're assuming this is a base 2 number, okay, binary number. All we have to do is, where are the ones? Okay, I'm not giving you any $128 bills, no $64 bills, no $32 bills, no $16 bills, no $8 bills. I'm going to give you a $4 bill and a $2 bill and no $1 bills. So what am I giving you in decimal? 4 plus 2, the value is 6. Now, if you're in one of my classes, this number up here means something. Okay, I have a little quiz that we do, or a little homework. And that's just showing you the number associated with that assignment. Okay, 4 plus 2. All right. How about this one? What do you think? Look at this a while here, just a moment. Where do we have ones? What did I give you as far as dollar bills? Okay, I gave you a $128 bill. An 8, let's see, no 64s, no 32s, no 16s. I gave you an $8 bill. I gave you a $4 bill. I didn't give you a $2 bill. And I gave you a $1 bill. Now, I can give you 1 or 0 of it. That's my only choices. Okay, I can't give you 2, 3, 4. I can give you 0 of a dollar bill, any of these value dollar bill, any of these currencies, I guess, that I'm using for my analogy, or 0 or 1. That's it. All right, so you can see wherever the ones are, add it up, and there's our answer. How about this one? Okay, yeah, we have 64, an 8, a 4, and that's it. So what do we have? 76. How about this one? I have 128, and it's 1 or 0. That's all I can give you, right? Of any of these. $128 bill, a $64 bill, and nothing else. Now, do I need these zeros here? Yes. Without these zeros here, I would assume that the 2 ones were over here, and that would be 3. Okay. So this is 192. So leading zeros don't matter, but the following zeros do. Okay. I mean, if in the world of decimal, okay, if I owed you $50, okay, if I just did that, if I said, okay, I wrote you a check, nobody writes checks anymore, but okay, if I said, wrote down, this is what I owe you, go, no, you need a 0 there. Oh, 0 here? No. That's okay, but this is where I need the 0, right there. This means $50. So we need to put those zeros, the following zeros. All right. What else we got here? Oh, here's a long one. Okay. All right. People are getting out their calculators. 128 plus 64 plus 32 plus 16. And we don't have to add any of these. That is 240. Okay. Now let's go the other way. What if I gave you a decimal number and said, tell me what the binary is? Okay. It's exactly the same, only different. Okay. For example, let's say I owe you $14. Now, I'm going to pay you in my binary currency. Okay, $1 bills, $2 bills, $4 bills, 8, 16, etc. And I can only give you 0 of it or 1 of it. That's it. Now, am I going to give you $128? A $128 bill? No, I'm not going to give you that. I only owe you 14. Am I going to give you a $64 bill? Nope, I'm not going to do that. Am I going to give you a $32 bill? Nope, I only owe you $14. Am I going to give you a $16 bill? Nope. Am I going to give you an $8 bill? Yes. Okay, that takes care of part of this. Now, what do I still owe you? I haven't given you everything yet, have I? I've only paid you $8 and I owe you 14. Okay, so I'm going to subtract the 8 and see what I still owe you here. And now I owe you $6. Okay, so am I going to give you a $4 bill? Because I still owe you $6. And yes, I'll give you a $4 bill. Okay, so let me subtract that and see what I owe you now. Now I owe you $2. All right, so am I going to give you a $2 bill? Yes. Okay, let's subtract that. And now I don't owe you anything. But am I giving you a $1 bill? No, but be sure to put the 0 here. That's important. These zeros here don't matter. These first 4 zeros. The 0 here matters. Otherwise, these 3 ones shift over. Okay. So we want to make sure that this one is an 8, this one is a 4, this one is a 2, and the 0 here is 0 ones. Okay. And how can we make sure that this is correct? Okay. Well, what you can do is just wherever you have a 1, add these digits right here. Wherever we have a 1, add those up. 8 plus 4 plus 2, 12, 13, 14. Yep, 14 right there. The beauty of math, okay? It just very, no exceptions. The rules apply all the time. Very easy to work with. All right, I think I show you this here. 14. So not going to give you any of those. I'm going to give you one of those. We subtracted the 8 from the 14, 6 left over. Still owe you $6. The 1, okay, yes, I'm going to give you the 4. We did this already. $2 left. I gave you a $2 bill, and we're all set. Okay. So this is what I'm going to use for the next couple. Something similar. $18. I owe you $18 now. All right, what am I going to give you? Okay, you can see I've already kind of given. Sometimes you can eyeball it, right? 18, where am I going to put ones? Where am I going to put ones? I'll put a 1 here where the 16 is, a 1 where the 2 is. And don't forget the zeros here, 8, 4, and here. These zeros here don't matter. So sometimes you can eyeball it. Okay? But let's go ahead and go through this. I owe you $18. I'm not going to give you $128. I'm not going to give you $64. I'm not going to give you $32, but I will give you $16. So let's see what I owe you now. I did owe you 18. Now I gave you 16. I now owe you $2. This is the new amount. Okay, we're going to give you $8. Nope. We're going to give you $4. Nope. I only owe you $2. And we're going to give you $2. Yes. Again, I give you 1 of it or 0 of it. That's it. Base 2 digits. All right. So let's subtract that. See what I owe you now. Now I owe you nothing. Oh, don't forget that 0 there. Okay. We don't have 1 left over. We have 0 left over. Again, 16 plus 2 is 18, where we have the ones. See how simple this is? This is fun. Okay. All right. Let's look at this one. Sometimes a big number looks scary, but as soon as we start, subtracting some of these numbers, it's pretty easy. All right. You might even be able to eyeball this one. I owe you $130. Can I give you a $128 bill? My choice is 0 or 1. Yes. Okay, so I'm going to give you one $128 bill and subtract that. We're at 2. Now it's really easy, right? But don't forget these zeros. Okay, I'm not going to give you any of these because I only owe you $2. But I am going to give you a $2 bill. Subtract that. Now I owe you 0. I'll put a 0 here. Now, if we did a subtraction, by the way, all of these, I probably should have some odd numbers, but these happen to be all even numbers. Even numbers will have a 0 here in the ones position. Odd numbers will have a 1 here in the ones position. So if this was 131, then I would be owing you well, let me show you that. Let's do that real quick here. Okay, what if this was 131? Okay, give you one $128 bill. Okay, so we subtract the 128. I'll do it this way here. And we have 3 left over. Okay, of course, I'm not going to give you 64, 32, 16, 8, 4. I only owe you $3. Oh, I will give you a $2 bill. Okay, we'll subtract the 2 from there. And now I owe you $1. Will I give you a $1 bill? Yes. 128 plus 2 plus 1 is 131. So here's the difference. You notice that this first one, 130, was an even number, so it had a 0 here. 131 is an odd number, so it's got a 1 there. Kind of cool. All right. 192. This might look scary. Let's start. You can see the answer. 192. Am I going to give you a $128 bill? Yes. Subtract that. Now I owe you $64. Oh, that made it really easy because our next value is 64. So I'll give you a $64 bill. Do our little subtraction. Now I don't owe you anything. Am I done? No, don't forget to put the zeros here. Okay. Otherwise, this 1, 1 would look like a 1 here and a 1 here, or 3 instead of 192. Okay. All right. Kind of cool. Uh-oh. This one looks tough. You know how to subtract? We're good. Okay. I might have to use a calculator. Okay. But it's only simple subtraction. 246. Am I going to give you a $128 bill? Okay. Yes. So let's do that subtraction. 246 minus 128 is 118. So as long as you can just subtract, you're good. All right, now we got 118 left. Forget this number over here. We're looking at this number here. 118. We're going to give you a $64 bill? Yes, because I still owe you $118. So we're not done yet. So I give you a $64 bill. I'm going to subtract that from what I owed you after I gave you the $128 bill. So 118 minus the $64 I give you, I still owe you $54. Am I going to give you a $32 bill? Yes, because that will help decrease it. So I'll give you a $32 bill. Subtract that, 54 minus 32. Now I still owe you $22. And we're going to give you a $16 bill. Will that help? Yes, it will. So let me give you a $16 bill and see what I owe you now. I did owe you $22. I just gave you a $16 bill. Now I only owe you $6. Now you can start to eyeball it, right? All right. Am I going to give you an $8 bill? No. I'm going to give you a $4 bill? Yes. Okay. Owed you $6. I just gave you a $4 bill. $2 left over. Okay, and we're almost there. Do I owe you, let's see, I owe you $2. Am I going to give you a $2 bill? Yes. So let me give you that. Now I don't owe you anything. Let's put that 0 there. This is what I owe you. Now, once again, wherever we have these ones, if I add those numbers, oops, I have to do it like this here. If I add wherever I have a 1, okay, wherever I have a 1, if I add the 16 plus 64 plus 32, did I say 16? 128 plus 64 plus 32 plus 16 plus 4 plus 2. If I add all those numbers up, that will give me 246. Just follow the simple steps. All right, good job. Next video, I'm going to talk about hexadecimal, but you can do it because you know how to do this. You know how to do base 10. You can do any of this stuff. All right, hope this video helped.